Hello, my name is Kaarel Kaljurand and I work for the Attempta project at the University of Zurich. The Attempta project is part of the Reverse project, and our goal there is to develop natural language-based user interfaces to formal semantic web languages. In the screencast I will demonstrate how formal ontologies can be written in controlled English. We're going to work with the semantic web ontology language OWL, and we're going to use the popular ontology editor Protege. But the focus of the screencast is not Protege, but a plugin called AceView that we have developed. So Protege is only a host environment providing, among other things, automatic reasoning services. The actual editing of the ontologies is done via this new plugin in the AceView. So what is ACE? ACE is short for Attempta Controlled English. It's a controlled English developed in the Attempta project. And among other things, ACE allows us to read and write formal OWL ontologies in English. It therefore hides the formal and complex nature of OWL behind the familiar English syntax. We'll see shortly what it means. First I will briefly introduce OWL and Protege and then move on to explaining the role of ACE. So in OWL the distinction is made between classes, object properties, data properties and individuals. And I've prepared a small ontology that I'm going to use in this screencast. It's about the solar system. First let's explore the classes in this ontology. We see that OWL lets us say a lot of things about classes, and there are different ways of saying those things. Some are visual, less expressive. For example, in this tree view we can express that every moon is a celestial body, every dwarf planet is a planet, and so on, and everything is a subclass of this artificial class thing. But there are also views where we can express more complex notions. So about the moon we can say that it's a celestial body and it orbits a dwarf planet, or it orbits a planet. Here we already see a usage of an object property. We can define object properties such as neighbor and orbit independently from classes. We can assert certain properties of such properties. We can say that orbit is irreflexive. Our ontology does not contain any data properties, but it does contain some individuals. We have modeled the celestial bodies like Sun and Earth as all individuals. For Sun we have said that it's a star, and for Earth we can say that it's a planet. So as you can see, the default interface that Protege provides to OWL editing is quite complicated. There are lots of tabs. Each tab contains several windows, and each window furthermore has several subsections with sometimes hard to understand labels. And sometimes we can easily express something by, for instance, checking a checkbox. Of course, in this case we have to know what irreflexive means. Sometimes a tree view is provided and we can easily edit this tree view. We can move things around. But often when we want to say something more expressive, we have to go and edit such complicated formulas. So in our work we have tried to simplify the interface to OWL. The AceView window or tab displays the complete ontology in natural language. So the complete ontology is displayed here as 10 natural language sentences in one text area. There are other more structured views. For instance, the ACE words view displays all the words in the ACE text, and the words correspond to all entities like classes and properties and individuals. And by clicking on the words we can see the usage of this word. For instance, the word orbit is used in 2 sentences, nothing orbits itself. This expresses this irreflexivity, and every moon is a celestial body that orbits a dwarf planet or that orbits a planet. This expresses this complex owl axiom that we saw earlier. And in this view we can click around to see, in this case, the definition of a planet given as 5 sentences. There is also a view which displays all the sentences, or sometimes such a snippet can contain several sentences in one list. It's sortable, and for each sentence we can see its properties. If the sentence was not parsed, if it contains a syntax error, then we see an error message here. Otherwise we see the corresponding owl axioms. And finally, there are views which display ACE questions and answers to them, and entailments, so sentences which are entailed by the ontology, but we will see soon how those things work. So, as you can see, ACE can be used to verbalize all ontologies, especially in case one is not familiar with the formal syntax of OWL or the interface that Processor provides for it. But that's just half of the story. Behind the scenes, ACE is also a formal language. Simply its syntax is natural language-like. This means that no information gets lost during the verbalization, and we can in fact modify the verbalization and translate it back to OWL with no loss in information. For instance, we can add a new sentence saying that no planet is a dwarf planet, and add it to the ontology. When we click on the planet, now we see that one further sentence was added to the definition, and we can explore the corresponding OWL axiom here. Now if we run a reasoner, for instance pellet, and check the entailments, then we see certain sentences that the ontology did not mention, or our ACE text did not mention, but which nevertheless can be derived from this ACE text. For instance, Earth is a celestial body, and when we double click on this newfound sentence, then we also see the reason why the ontology or the ACE text entails this sentence. So we have said that Earth is a planet, and we have said that every planet is a celestial body. Sometimes we find strange sentences like nothing is a dwarf planet, and again a reason is displayed here. We have claimed that every dwarf planet is a planet, but on the other hand we have also claimed that no planet is a dwarf planet. So we have to fix this problem. And one way to fix it, so we can delete this sentence, or we can use the protege interface and simply move this particular class to being a subclass of celestial body but not a subclass of planet. Then we have to run the reason again, and now this entailment, nothing is a dwarf planet, disappeared. And of course this sentence has disappeared from our ACE text as well. It was in fact replaced by a new sentence, every dwarf planet is a celestial body, just by this move that we did here in this tree view. Now where we can also profit from inbuilt reasoning is question answering. For instance, we want to know what is, according to our ontology, a celestial body. What is a celestial body? Let's add this, and let's add another bit more complicated sentence. What is a celestial body that is not a star? And now, running the reasoner again, we see those two questions answered. So what is a celestial body? Earth and Sun, and every dwarf planet, every moon, every star, and every planet is a celestial body. What is a celestial body that is not a star? Only Earth. Of course, the list is open-ended. Simply only the individuals or only the proper names that we have explicitly mentioned can be listed here. So in fact, every planet, not just Earth, is a celestial body that is not a star. This comes from the fact that we said that no planet is a star. And we can actually go beyond. So in addition to simple axioms or all axioms, we can state questions and get answers to them. But we can also express more rule-like sentences which OWL cannot express, but which the swirl rule extension to OWL can express. For instance, here we added a sentence: if a planet orbits a star and orbits a star X and orbits a star Y that is not X, then X neighbors Y. And this was converted into such a swirl rule because it couldn't be converted into OWL. By the way, the metrics window also displays this. And in the OWL in the standard protege view, this rule is displayed like this. So, in conclusion, the ACE view offers an easy access to all ontologies. One can view and change all ontologies without having to learn the complicated syntax of OWL or the interface that Protege provides for it. Thank you for listening.